Hi everyone, welcome back. Welcome to my another video. And in this video, I'm not going to talk about Uber Eats clone, but something else. So initially, when we were designing or discussing the Uber Eats architecture, we decided we will do it in the GraphQL. Okay, this is like my front-end interfaces, multiple front-end interface. We are going to use the GraphQL gateway. This is a Svelte kit. This is a Next.js. This is a React app. See, this is a React. This is Next.js app, or this is Svelte kit app. This is somewhat we decided, and this we thought about, okay, it should be a GraphQL gateway, something like that, and these all will be the Apollo GraphQL services. Let me just detach these nodes. This GraphQL gateway, and these all are subgraph services. This is what we decided. Then I thought, like, okay, the first version, I don't want to make it complex. This is a user service, auth service, auth service is same as user service, order service, card service, restaurant service, and all these other services. Then I moved down that concept to just having one proxy as a API gateway. Here it is now replaced here in the current Uber Eats clone which I'm building. This is just a proxy, and here I have some of the Nest.js REST APIs we are using, but there is already another content I wanted to create parallelly. It's not a full stack clone app or something, just a couple of videos, 5-6 videos to give you the feeling of how we can achieve the same kind of concept of multiple microservices and with the GraphQL gateway using Apollo GraphQL Federation. So Apollo GraphQL Federation. This is actually not a new concept. This is now available and people are using it. This is really a nice concept in which what you can do is it allows you to create a gateway, and then it can consume the subgraphs provided by auth service or your restaurant service or another microservice. Let's say another service, and there can be another service. We'll not name it because we can be building anything. So this GraphQL gateway will be composing the subgraphs, because these all will be built in top of Nest.js plus GraphQL, having their own database and running on the Docker or locally, because we need to build a lot of applications, like a couple of 3-4 microservices to orchestrate this thing. Okay, these set of things will be common for all the service which we are going to run. This will also be using the same Nest.js GraphQL with Apollo. We are going to use Apollo because Nest.js under the hood uses the Apollo GraphQL. It has its own modules, Nest.js GraphQL, but that under the hood uses the same thing. Okay, now my objective of this playlist is to talk more about Apollo GraphQL Federation, which gives us the GraphQL gateway or GraphQL router and can compose the subgraphs coming from the multiple microservices. You will host it somewhere else, you will host it somewhere else, and then we'll put this router in front of your front-end apps. They will connect to this GraphQL gateway, and all the queries and mutations coming from all these different microservices will be composed from this gateway, and only this gateway will expose all these things. It's like the gateway, whatever the gateway responsibility is, it will do the authorization, it will compose all the queries and mutation subscription through this gateway. So your front end is dependent on this, and he doesn't know, your front end doesn't know, okay, under the hood there are multiple microservices doing the task. And I will be talking about Apollo GraphQL Federation. It has nothing to do with a Uber Eats clone, but parallelly we are talking about all these things. Even the Svelte kit playlist is running parallelly. So Svelte kit, like, okay, I wanted to build front end with Svelte kit or Next.js or maybe React client-side rendered application. So here this is really a fun part. If you're already working on the GraphQL, then you might have already used Nest.js GraphQL, how it works. Now we will build a couple of services in the Nest.js GraphQL. We'll compose those subgraphs through the GraphQL gateway, and then there will be a consumer will consume them. Let's say recently I created a auth service using simple REST API because it is just exposing the REST interface. Let's say if I build a REST GraphQL service, same as auth service, right? The interface I changed. The tools and technologies are still the same. I'm using the NestJS with the GraphQL. Instead of REST APIs, I will be exposing the GraphQL interface. Then I built a couple of more services, will be exposing the subgraphs, and then this GraphQL gateway will be composing all the subgraphs. So it's like a fun learning for me also, and I wanted to deliver it to you guys. So if you want to build another modern product in future, which where you want to play with the GraphQL, because the important part is it's not only just doing this composition, this GraphQL gateway, because let's say GraphQL means you are aggregating the data in a single query. Let's say user data is coming from auth service and the order data or product data is coming from other service. In the query, you will just mention a single query. Now this GraphQL gateway query plan will decide how to fetch the data from the auth service and some part of the data from different service. You don't need to worry about it, and this is really done under the hood really nicely and clean, in the clean way. Obviously all of the services should be up and running to fetch the data. So your GraphQL gateway is just aggregating the data and composing the JSON response based on your query. It's really fun learning. So let's dive in. I will talk about a couple of more examples. Okay, what is Apollo GraphQL Federation is. We will go through some documentation. We will write some services. We'll use Docker to spin up some containers like Postgres, Node.js container, which if you are following some of my playlist, you are already aware. You can skip them. So it's another playlist I'm going to build for building microservices in the NestJS, exposing GraphQL, and understanding more about Apollo GraphQL Federation in this particular playlist. Hi everyone, welcome back. Welcome to my YouTube channel, and here I am Tarun Sharma, and I'm going to publish one more playlist with the two playlists which I'm already covering: Uber Eats Clone and SvelteKit Advanced. In this playlist, I'm going to talk about this stuff, Apollo GraphQL and Apollo GraphQL Federation. You might have heard about REST APIs, GraphQL APIs and all, and you might even have already tried how to write the GraphQL APIs with the help of Node.js. Now, on top of that, we are going to talk about Apollo GraphQL Federation. Okay, I mean, this might be you might already be familiar with Apollo and GraphQL. This federation is a new concept which they have added. Okay, earlier you might be already writing GraphQL APIs with the help of Node.js, either Express or the NestJS, which is fulfilling the client queries and mutation. Let's say this is your GraphQL server, which is built on Node.js, and this is your client, which is sending what, query and mutation or subscription. So this is your client. Here what you do is you send a query or mutation or subscription. You subscribe to a particular change. So this is what GraphQL provides, and you are writing the GraphQL APIs. But we live in the microservice world. That means a single service can't give you each and every kind of data. So what we earlier doing is we were writing a multiple GraphQL services with the help of same Node.js GraphQL or NestJS GraphQL. So we were building these kind of microservices, and we were replicating. Let's say these are multiple GraphQL services we have built, and then we were writing code to stitch the data and merge the data and aggregate the data. Because let's say this is a user service. Okay, we'll talk in the context of microservices so it is more clear to everyone. This is an order service. Earlier there was a concept, okay, let's say you already have a REST APIs, then you can write a GraphQL gateway service which can aggregate the data coming from different data source. Either you have existing REST APIs or legacy system, you just write a wrapper and you should be able to expose the GraphQL schema from them, and the GraphQL queries can be triggered to fetch the data from those services. But what GraphQL Federation provides? Here it is, Apollo GraphQL Federation. I mean, recently I developed an application on the housing, and earlier also I did a POC on how it really works, and I'm really impressed that how it deals with the microservices. Okay, let's say here you have written a card service, or here you written a user service, order service. All are GraphQL services. I mean, you can actually fetch, you can trigger a queries and mutation directly to the order service, card service, and user service. They all exposes the schema. I mean, the query and mutations you can directly trigger to the user service, card, or order service. But I want to merge the schemas, because what they expose GraphQL schema, I want to merge the GraphQL schemas, and I wanted to provide a central gateway. So here I'm talking about this. This is a gateway service, and I just want to trigger a single query so that it can fetch a data from user service, card service, and order service. Let's say there is a query I'm sending from the front end. So front end is sending, front end is a UI, Android, or any mobile device or desktop or any kind of application. You will be using client library to send a query mutations. Let's say here I'm sending a query, fetch me the, I mean, there is a query which is asking a user data and all the orders which the user has placed in a particular duration, that you will send a query. Now this gateway will send a request to these two microservices under the hood, user service and order service. Will fetch the data, aggregate the data, and send the data back to you, because this is Apollo GraphQL router, I mean Apollo GraphQL gateway. Earlier I used to build the application like this without Apollo Federation. In that case I used to do a schema stitching manually, and I used to merge the data coming from user service and order service, and used to do that. But that has gone now. We will be using Apollo GraphQL Federation, and this Apollo GraphQL gateway will actually merge the schemas coming from the user service, card service, and order service, and then exposes all the queries, mutation, and subscription together, so that you can just send a single query, and this GraphQL router or the gateway is responsible for fetching the data from underlying services, user service, card service, and order service. You just need to use some special annotations that this is the shared data, and whenever you send a query, it is responsible for fetching the data from multiple microservices. So in the enterprise microservice world, this is really helpful. And when you see the code, that how it is working under the hood, you will be really impressed at how it is doing it. Because what we are doing is we are just exposing GraphQL schema. I mean, here these are like plain simple GraphQL services we are going to write, multiple GraphQL services, but obviously they will not be duplicate. You are writing a microservice world, there is a user service, auth service, and all, and every service is exposing some schema. This gateway, this router will be a centralized place to which we will be talking, and this gateway will stitch and merge the schemas coming from multiple services, so that at centralized I can send a single query and fetch the data. I don't need to do some additional things to merge the response or aggregate the data coming from different microservices. This is really an interesting playlist, because I'm going to touch all the concepts of GraphQL, Apollo GraphQL Federation. And this is the evolving concept, because what these services are exposing their subgraphs, and this router or this gateway is merging those subgraph and exposing a single graph, because this is the router, and the client will be sending a single query. Okay, give me the user products with the user data. So I need to fetch the user data from the user service and the orders from the order GraphQL service. And this router, this is actually the gateway. It is going to merge the subgraph exposed by different services like this. So this is Apollo router. I mean, the main concept is, the main restriction is this all should expose the GraphQL subgraphs. This cannot be REST API, this cannot be a data source, this cannot be some legacy system. This should be a modern system exposing the GraphQL interface. That is the restriction it is putting, and that is fine, because if you are building a modern service, then you can do it something like this. So this is the user microservice exposing the user types. This is the product microservice, and this is the review microservice. And here you can see you are actually passing the user reference everywhere. So it is like actually you can consider it like a join. You are creating a join here and giving the reference of user inside a cart or giving the reference of user inside order. So whenever you want to fetch the data, this gateway will do the join of data from the user service to the order service. I'm not talking about database joins here, but the references we are storing inside a schema. And based on these references, like user has the reference, like let's say product has the reference of reviewer, reviewer has a reference of user. So if I want to fetch the reviews submitted by this user, I'm able to do it because I already have the reference defined in the type definition of the schema, right? We will be defining the types, we will be exposing the subgraph from these different services. You can see this is the type definition of a review service, product service, and user service. So this user reference is already being captured by these subgraphs. So there is obviously some kind of a reference we need to put in the other subgraph microservice so that they can attach, or they know how to fetch the data. So if I wanted to fetch the orders of that user, users will be fetched from here, and then I already have your order service subgraph already has a reference of user. So they should be able to fetch the orders of underlying user, I mean based on the current session. So this is going to be an interesting playlist for me. Even I really want to teach this thing, Apollo GraphQL Federation, with a real world example. We will build a housing application where you can sell and buy the houses, and we are going to build the whole backend systems for this, and we are going to use NestJS for it. So it's all going to be the NestJS GraphQL ecosystem we are going to build. NestJS GraphQL services we are going to write. Apollo GraphQL Federation. Even I wrote a blog series on this. If you are interested in learning this, then these blogs will tell you how the Apollo GraphQL Federation really works. This is a little bit old, 2022, but that concept is evolving a lot. If you talk about the microservice world and how we merge the data and how we expose the data from different services through one single query or mutation. Okay, you can read this and you can just get to know more about this particular thing. You can see what this is doing. This is Apollo GraphQL gateway, and this is merging the schemas coming from different services and exposing the same schema through this gateway to all the other services. It's not only merging it. The responsibility is, let's say there's some client send a query to fetch the data which is coming from multiple microservices. So you don't need to do anything. This Apollo router should be able to deal with the data, how to fetch the data from auth service, planet service, and satellite service. We just need to configure the endpoints of this service, that service, and that service. What this Apollo server will do is, Apollo gateway server will do is, it will fetch the schema from this service, and that service, manage the references, and create a schema plan on this server. So when you send a query, it will detect, okay, from what all different places I need to fetch the data and I need to merge that data. So that is being done by the logic of this Apollo GraphQL gateway. Okay, that is Apollo Federation at the end. Okay, it's an interesting read. If you want to just learn about it, you can just go through it. There are 4 blogs, and I will recommend, if you just want to go through this playlist, either you go through these blogs or just stay tuned for my playlist. I will be covering a lot of really good concepts about Apollo GraphQL gateway, and the same concepts you can adopt in your microservice world. These can be independent GraphQL services. You write your gateway and send this unique endpoint, which you can authorize, authenticate, whatever the logic you wanted to place to your front end, to your clients. Client can be your desktop app, web app, or the mobile app. Okay, let's talk more about this in the coming videos. Hi everyone, and welcome back. Welcome to the Apollo GraphQL Federation sessions, and in this video we are going to talk about building the Apollo GraphQL server with the help of auth service. So we have like auth service. We are going to create a multiple microservices, auth service, booking manager service, and home manager service. So what kind of architecture I'm going to build? We are using Apollo GraphQL gateway, and I have 3 services: authentication service, booking service, and home service. And what is this application is about? I'm just building a simple application where you can buy homes. Let's say there are home entity and there is a booking entity where you can book the home, and you will be the owner. The logged in user who is going to buy will become the owner. So I'm not going to build a housing.com kind of platform, but I'm trying to create a backend platform for it, where user can select, okay, he's going to buy this kind of a home. So he will generate a booking, and then there is a home entity. We will build these three different microservices separately, which will be exposing the GraphQL interface, and then we will aggregate all those subgraphs through the GraphQL gateway. This is what we are going to do. So let's get started how it is going to be. These are the three services: auth service, booking service, and home manager service. These are the three services, let's say, we are going to build. And in the GraphQL, there are different approach of building GraphQL services. There is a code first and schema first. I mean, these are the two different ways to build a GraphQL service. There is no major difference. In one particular method, you are going to write GraphQL types, GraphQL schema dot GraphQL files. In another approach, you are going to write a TypeScript class. That is a code first. And another is a schema first. In the schema first, you will be using the schemas. In the code first, you will be using the TypeScript classes. So here you can see there are two different approach. Code first approach, you will use a TypeScript decorators because you are writing a code TypeScript classes. In the schema first, you will be using TypeScript schema definitions, which we are going to write in the .graphql files. That is a major difference. Otherwise, you will still write resolvers, services, all the other things are still going to be the same. So we are going to use a schema first approach. That means we are going to define the type definitions. I hope if you already know what is the basic GraphQL setup, you define a schema file with the with all the types, queries, and mutations. So here these are the modules I'm going to build, the same as authentication service. There will be some kind of a duplicates because in the auth service we have already built as a separate microservice, which is a REST-based service. Now it is a GraphQL, but there is a major chunk of code is going to remain same. The only thing is we are going to add a controllers. Instead of controller, we will be having resolvers in the GraphQL. So we are going to have a user module, domain module, config module, database module, logger module, swagger module. All those things are going to be the same. The only thing is inside a user module and auth module, we will not write controllers. We will write resolvers, and we are not going to write DTO classes. We will write we will get the types based on the schema file. Okay, so we are going to write type.graphql files, and controllers will be replaced with the resolvers. In the resolvers, we will define the query, mutation, and the subscription. If we see the code, what do we do inside resolvers? This is how we are doing it in the code first. In the schema first, we are going to define the resolvers class something like this, and we are going to add a query, @query, @mutation, @subscription. These are the three common stuff we are going to use. Query to fetch the data, mutation to change the data. Like you in the REST API, you do a get, put, post, delete, patch. So similarly here, mutation is we will be used to update the data in the database. Okay. So inside the resolvers, there are we will write query, we will write mutation, we will write subscription. So this is how GraphQL works. In the GraphQL definition of your APIs, it will expose all those three things, and this is how we are going to write a subscription, where you are going to subscribe to a data change, and server will keep sending you the events when the data change. And this is how we are going to initialize the module, GraphQL module.forRoot. Okay, what we are going to do is we are going to have three services. Currently the package is empty. Let's add them. So what we will do is a nest CLI, nest new auth service, nest new booking service, nest new home service. Using these three different commands, we can create it. I will switch the node version and I will just add auth service. It is just bootstrapping the skeleton of a NestJS app. And then this is the part one of the video. So what we are going to do, we are going to create a folder structures. In the folder, we will just create a simple auth, user, okay, and the domain module. Inside domain folder, we are going to put auth and user, and then we are going to create a logger, database, config, documents, the swagger. Inside domain, we will have two folders. One is, let's say, user, and another is auth, because these are the two main modules, and we are going to create their separate services, resolvers, modules, all those separate things we are going to put here. And this is the Docker Compose, same as the earlier example. This is going to create a database. Now we have three services. what I will do is I will just create a simple Docker Compose file is enough to spin up the 3 containers, creating 3 different database. The Node.js we will just run from the terminal. npm run start dev, npm run start dev. Postgres database we will have inside a Docker Compose file. So I will do Docker Compose up. Okay, this is not creating. I need to restart maybe the Docker. So this is my Docker Compose file. Inside this I have just one image, Postgres auth, Postgres home, and Postgres booking. These are the 3 different images we will have. And inside Docker Compose override, I just put a port definitions and the volume mapping. That's it. I'm creating a booking service, and then we can create another NestJS app, which is a home service. And then once it is started, what I will do is inside Docker Compose YAML, I will update it and I will create 2 more containers for the database. Or in one container you can create a 4 database, but that's fine. I'm going to create a 3 different database exposing 3 different host port, and Docker Compose up, and you can see it has spin up all the containers. At least there is a 1 container right now. What we can do is we can spin up all the containers. So what we will do is we will just copy paste it 3 times. This is a Postgres auth is the container name, so it will be a booking, it will be a home. So we have a 3 containers. Same, we will update the Docker Compose override and create the 3 different copies for it. So Postgres auth, Postgres booking, Postgres home. We just need to change the host port because host cannot have a two containers cannot have a same host port. The container port can be same because these are separate isolated containers. And now I will just change the name of booking API data. The volume mapping will be changed on the host, and we'll just copy paste it 3 times. This is the home API data, booking API data, and this is the home API data. And then we'll do a Docker Compose up. Just stop it and Docker Compose up. So what it will do for me, it should create a 6 databases, two database per container, like auth API testing, home API testing, and the booking API testing, right? 2 container on each container, and we'll do a Docker Compose up now. That should create all the containers, and yes, we got it. There are 3 containers are running. We are good. Now rest of all the setup is creating the basic skeleton, because this is the part 1 of the setup. We'll just create some folder structure. Inside each and every folders and modules, we are going to create a domain module, and we will see how to write a schema first module, because if I want to use type ORM, how I do is type ORM module.for root. Here I'm going to use a GraphQL module, right? So I'm going to write the GraphQL modules for that. I will include NestJS GraphQL module in the dependency. So before that, I'm just creating these .graphql files because it's a schema first. I'm adding resolver, I'm adding service, I'm adding the modules. I have 2 main modules. Like in the auth, we are going to also use auth strategies, auth guard. Now these things I have already discussed the same thing in the REST API microservice because same authentication service we created there. I'm going to build some same kind of stuff. So a lot of things you are already familiar, so you can skip the video if you're already familiar, and you can focus only on the GraphQL part. So here we created a user service, user module, user types.graphql, and user resolver. And then because we have a user module, user GraphQL, you can put interface and all. But now inside a domain, because we have a domain, so we will create a domain module, or in the domain module we will put the user module and auth module. So this is the domain module.ts, and this is my app module. So in app module you will import domain module. Inside app module, in the domain module you will put a user module and auth module. This is how it really works. We added an entity. So here I'm going to create orm config.ts to run the migrations and all before creating a database module. So after that we will also create a database module, config module, logger module, and swagger module, swagger config. Here logger we are going to add. Now domain module or a user module, how it looks like, you will be just importing the resolvers, the services, all these things. So how we create a simple module. We import all the dependencies, define all the controllers, define all the providers, define all the exports, right? This is a user module. Similarly, we will define the domain module, and inside a domain module, we are going to initialize our GraphQL module. Okay, so there we are going to create the real module, because domain module is a root module. There we are importing a user module, an auth module. So whatever is the common modules, we can put the GraphQL module definition inside the domain module. So here we are going to use GraphQL module. For that, obviously, I think we need to install dependency that we haven't done now. So it should be coming from the NestJS GraphQL, and we'll just do npm install -- save NestJS GraphQL and GraphQL module. I think there is a typo. GraphQL module.forRoot is a method. There we define all that. Where from, I mean, this is the module which will do our GraphQL stuff in the NestJS service, right? NestJS framework independently provide this module, so you can write the GraphQL services. Here we'll just GraphQL.forRoot, and we specify the type, path, context, and driver. Driver is important part, because the driver we are going to pass Apollo Federation driver, because we are going to use this service with the Apollo Federation gateway. So first, this driver is important part, and this driver must be Apollo Federation. And we also need to install the dependency NestJS Apollo and Apollo Federation driver. And here in the context is the, if you remember how we write the GraphQL server, we pass the context to populate the request object, and the definitions, like what is the place from where I can look for .graphql files. We have GraphQL files inside a user module and auth module. GraphQL files we will define a schema, the type definitions and all. So this is the output file which you are going to generate after looking at those GraphQL files. .graphql, you can see in the type path we are passing .graphql files, and we are going to generate this output class. Okay, so this is pretty much the GraphQL module we are going to build. Same GraphQL module we are going to build in all the 3 different services, and from there we are going to expose the schema. Here Apollo Federation driver, because I'm going to use this with Apollo Federation, and in type path I'm passing all the .graphql files. So the path pattern is fixed. We have it in the user and auth folder. So this is the part 1. Let's see in the part 2 what we are going to do is we are going to write the rest of the setup, which is like the whole complete baselining the GraphQL service, and we'll just run it, and we will just see what it is exposing. And then we will start writing the auth module and the auth module and the user module, where we are going to define the user service. User service will have the same user sign up mechanism, and auth module will have a login and all the different APIs we have built in auth service. We are going to divide them into user and auth services, and we are going to define the query and mutation. Queries means I want a user data. Mutation, I wanted to create a user, update a user, I wanted to just log in a user, delete a user, and I wanted to just generate an access token based on the login. For those we will be using the query, mutation, subscription. We don't need it. We are going to write a JWT strategy, because once user is logged in, user is going to come back with authorization header. So we are going to use the same JWT strategy, auth guard, and all the concept which we discussed earlier. Hi everyone, welcome back. So this is the part 2 of baselining a GraphQL services with all the required things, all the dependent module, controllers, resolvers, services, type definitions and all. Okay, so what we are going to do here is, this is our user module. Okay, sorry for the typo. And this is our auth module. And what all other things we are going to have, which we already know. Okay, we have a database module, config module, and logger module. We'll put them here, because these are like at the root level, at the domain level. Logger, database, and maybe a config module. So all these are available inside user module, and this is our domain module, where we are going to inject everything, and this is our app module. This is our main.ts, bootstrapping the application. That's it. Here we are using NestJS GraphQL. This is the module, and NestJS Apollo is another module, I guess. I think these two modules are doing the main of the magic, and apart from that we are using NestJS type ORM and all the other modules, right? So user module, here what all components we are going to define. We already have a dot GraphQL file where we are going to define the type definitions, the query mutations, input types, and custom types. Here we are going to write a resolver where we will write the query mutations and all. I mean the actual methods, the implementation of whatever we have defined inside a .schema file. It's a schema first approach we are using, not the code first. And then we have a service like user service, auth service, and this is the module. This is the user module. Same components we have here in the auth module. We are going to write a query and type definitions for simple login, refresh token, validate. So .GraphQL file, resolver for all the methods, all the queries and mutation you have defined inside schema file. We have a service, and then we have module, right? So these are the two modules we have, which are going to, we are going to add that in the domain module. Then we already have these database module, logger modules, that obviously we are going to add it to the domain module, and if required we can add them at the module level, like in the user module and auth module we can add them directly. Okay, and this domain module will be added to the app module, and then we have a main.ts file which will bootstrap our application, a simple layer. Now what are the major components? Resolvers. Here we are going to use a new annotation resolver like annotation injectable. In the .GraphQL file is a simple schema based file. What it contains is just a type definitions, queries and mutations. Okay, so we are going to write custom types, and all those things will happen here. Now we will try to understand this thing, what it does. So these are the queries which this service is going to support. That means these are actually the GraphQL types, underscore add capital user. These are the types we are going to define, that will have a username, password, email and all. And this exclamation sign means that is a required property, because when you are doing user by ID is required, and it is going to give you the single user object. This is going to give you an array of users. Okay, forget password is going to return a boolean. These you are going to put inside your schema, and then inside your resolver you are going to define all these methods. So how your resolver looks like, inside your resolver you are going to actually write these methods. So I'll just put a simple snippet that will help you to understand. This is my simple resolver. What this resolver is saying is, okay, I can respond to this user query which is returning user as an array, right? So this is typically my resolver. And then we already know how to write a service, because this resolver is dependent on service. It has injected a user service there, and it is doing await this .user service .get all user. So we already know we will define this get all user method inside a user service. User service will be dependent on the type ORM repository, which is provided by database entities. Okay, here we are going to have entities also, all the user entities, because here there is only one table. So here we have a user entity, right? That will create a table, because we are going to use a NestJS type ORM which will bootstrap our database table. We already have a Docker Compose setup, container of database is running. So same process we will do for this auth module, user module, auth module will do the login, refresh token, validate and all. And on top of that we are going to use the same auth guard and JWT strategies once it is set up. Here we are going to add auth guard and JWT strategy. What they will do is they will sit on top of your resolver. right? So if, let's say if you are logged in and you are sending authorization header, so before going to the resolver, like get me this user data, I need to first pass through these auth guard, gwt guard, validate the token and validate the expiry and give you the user object. So this is pretty much the structure of this module. There is no major change, only now we have a .graphql file and the resolver. And what this .graphql file will do is, this .graphql file will generate the types. When you do npm run start with the basic setup, it is going to generate a .ts file that we will see, and those types you can use inside a resolver, like create user input, find user input. All these types will get created once you bootstrap the GraphQL application, and then you will see you can use them inside a resolver. So resolver is your controller. There you are defining query, mutation, subscription. Like we were writing controller in the REST APIs, like we were writing a simple controller file. Here we are writing a simple resolver file. That's a major difference. We are defining .graphql file, and at the main module, what we are doing is we are actually using this GraphQL module .for root. If you remember the syntax we were using in the last video, what this does, or maybe this is a little important. Here I'm looking for all the .graphql files, and it will generate this type inside a source folder. Those I can use as a DTO, and this is the context. This is the driver, Apollo Federation driver, because I'm going to consume this subgraph in the Apollo Federation router gateway. Okay, this you can put inside your domain module. This will sit inside your domain module. Okay, and then all the injection, you will put all the modules in the domain modules, and domain module you will put inside app module. So this is pretty much the folder structure and skeleton look like. This is a schema first. In the code first, you don't write a .graphql files, you write a models, TypeScript models instead of .graphql files. So you don't need to generate the types and all. But I love writing a GraphQL schema, because this is how the GraphQL is initially built. You write your types, queries, custom input types and all, and then you just write a resolvers for that. So here we are. What we will do is we'll try to set up these things. Here, this is my user entity. Okay, and I will just add all the dependencies like type-orm, NestJS type-orm, Postgres, all the required modules I will add, like NestJS Apollo, NestJS GraphQL. This entity is a database entity. Now this entity, I will be writing database module, config module, logger module for all those things. For now, I will just show, and I will just comment this code, database module .for root, and I will pass all the entities. Currently in this microservice, I have only user entity. So I will just pass it, and then once this, if you see this domain module, what do we have? It is going to have all the modules inside it: database module, auth module, config module, logger module, and then all the user module and auth module. Okay, so we will create all these separate modules together: database module, config module, which will populate the configuration from process.env, from your .env file to process.env, and the logger module just to do some logging and debugging purpose. Okay, so here we are going to define the types. This is really important to understand. If you are looking at the GraphQL for the first time, we use type query, type mutation, and for custom types we use input, like input types which you are passing in these methods. So query means you are requesting data, like give me the users, give me the users by ID, give me the users by email, give me the users by ID, email, update password, forget password, reset password. These becomes mutation, because there you are changing the state. So we are defining this user type, which contains ID, email, permissions, is a string array, first name, and you can see this exclamation sign. That means it is required. First name is required, last name is required in the user entity. I mean in the user type, the name is also required. So this is query, and picture URL, logo URL, I think that we can skip for now, and created it and updated that is of type date. So date is a custom scalar date. And here we have a user. Now what is the query? Query means give me the user by ID, give me the user by email, and find all the users. All these are queries. You are requesting your microservice to give you the data, so all those are annotated with the query. And here you can, I'm creating custom user input. Find users. I can find user by email, first name, last name. So attributes are optional in the find user. So here I created a custom type input find user input. So we will define this custom type as an input type, because for the GraphQL find user input, they don't know. They know only string, boolean, number, object. These are the GraphQL pre-built type. But when it comes to custom, you need to define them as a input property. So here we can define that using input, I guess input find user input, and then define all the properties. And here this is the find user input. So email optional, first name optional. We are not going to use the exclamation sign because this is optional property. And what Apollo GraphQL server will do is it will look into this schema file, and they are going to generate a DTO for us once we bootstrap our GraphQL system, and those details